Worksheet 5.2a, we're doing polynomials, linear factors, and zeros. We want to be able to sketch graphs, but we're going to do a little bit more accurately. We want a little bit more detail today than what we did yesterday. Yesterday, we talked about end behavior. And if you look at problem number 1, you can still see that end behavior from this first term. The fact that it's a exponent 2 tells me it's an even function, and the fact that it's a positive coefficient 2 tells me that this thing goes up and up. But today we're going to be a little bit more concerned with what happens in the middle of that graph, and I'm just going to use Desmos to do that. So go to Desmos and just type in that function, 2x squared minus 3. Later we might be more concerned about some of these numbers right here. But for now, I just want a basic idea or a basic sketch of what that thing looks like, okay? So what I mean by that is we're going to draw the axes, and we're just going to kind of sketch what this graph looks like. Not super concerned about the numbers or the intersection points. That's good enough. Sketch the general shape. That's good enough for now. Problem number 3 is a little bit more complicated. Again, from yesterday, we can see the end behavior. This is a negative and it's an odd. So I know my end behavior is going to go like this. But we want to know a little bit more about what's in the middle, and that's where Desmos is going to come in. Negative x cubed plus 2x squared minus 1. Not minus 1, plus 1. Negative x cubed plus 2x squared plus 1. Okay. So we can see it crosses the y-axis at 1. It goes up to about 2.1, and then it crosses again at about 2.2. I'm not super concerned about those details at this point. I just want to have a general sketch of what this looks like. It's down, up, and down like this. Okay, pretty good. That's a pretty good general sketch. Now in number 5, we want a little bit more detail. Find all roots and their multiplicities, then draw a quick sketch. Okay, roots are solutions or zeros. Sometimes if you want to say zeros, that maybe is easier to understand. The roots of the solutions are the zeros, and we've done that before, especially when we've factored. When we've factored, what we did was we looked right here and we said that has a 0 of negative 5. And this one has a 0 of negative 1. And this one has a 0 at positive 2. Okay? So what that means for my graph is it's going to cross the x-axis at negative 5 and negative 1 and positive 2, just like that. Okay? We can also talk about the end behavior. Now listen carefully, because this is confusing for some people. But the end behavior has to do with if I multiplied all of those factors out. If I FOILed them or distribute or whatever, simplified that so I don't have any parentheses. I don't want to do that, and I don't need to do that, because I can just look at the first term of each of the expressions there. Notice how this x is going to end up being squared. And this x is only to the first power, so that's just going to be an x. And this x right here is going to end up being squared. You can kind of see what would happen if you multiplied all of that out. You would have an x squared times an x squared. That's a total of 5 x's, or x to the 5th. This is an x to the 5th graph. If I multiplied it out, it would be x to the 5th plus blah, blah, blah. I don't really care about the rest of it, because it's that first term that determines the end behavior. When I see x to the fifth, I know that it's an odd and positive. So I know my end behavior is going to be like this, down and then up. I can see my end behavior is going to be down and then up like this. So I can kind of tell something about that graph, okay? But when they talk about multiplicities, this is probably the hardest part of the lesson. Talk about multiplicities, okay? All I'm talking about is the exponent on each of those zeros. So this first zero has a multiplicity of 2. And all I'm doing is looking at that exponent. And the next zero, the -1, has a multiplicity of 1. And the 2 has a multiplicity of 2. Just look at the exponent. Just look at the exponent. Okay? The significance of that is this. It tells you what the graph looks like at that point. So think about what an x squared graph looks like. You know how an x squared graph makes a parabola shape? Okay? Regular x is just a line. It's linear. And an x squared, well, there's a parabola shape, okay? That shape is what it looks like at that point, okay? So when I see this -5 has a multiplicity of 2, I can see the end behavior means it's going to bounce. It's going to look like this. It's going to have a parabola shape right there, okay? And which other one has a multiplicity of 2? The -2 also has a multiplicity of 2. So check it out. If the end behavior takes me up, it's going to look like this. Okay? And then the -1 has a multiplicity of 1. Imagine if you had to trace that shape. If you had to trace that shape, you can see that it's going to have to go straight through this point right here. Okay? It's going to be a straight line. So we can see the multiplicities just pretty much tell us how it behaves at that point. Let's use Desmos to kind of fill in the blanks, though. It'd be nice to know more specifically what's going to happen. So what do we have? X plus 5 squared, x plus 1, x minus 2 squared. Okay, so that's kind of hard to see, but you might notice your scale is different than the scale on the graph paper, so we can make it match. If you hit the wrench right here, we can change the scale. It looks like x goes from -8 to +4. And it looks like y goes from, I don't know, -250 to +150. Okay, check it out. We've got our parabola shape right here and one right here. We've got our end behavior is down and then up. But we can also kind of see some important points, like it crosses right here at 100. It goes up to like 105 right there. We already knew that it crossed here, but there's a minimum point right here at -201 or so. So it's kind of nice to have some specifics for when we draw our graph. Goes down to about -201, about -2.8 and -201. So there's going to be a point about right there. And it's going to cross at +100, but it's going to go up to 105 or so. So it's going to go up slightly right there. I don't know. That's going to look pretty good. So let's just kind of fill in the gaps here. It looks like this. And it bounces down. Okay, here's a minimum point. It's going to come straight up. And then curve back down. And then back up. Okay, try and draw it as nice as you can. Mine's a little bit wobbly there in the middle, but it looks pretty good. That's a pretty good indication of what we've got. Okay, so number 7. Number 7, okay. You know, we need to find the zeros, we need to find the end behavior, we need to find the multiplicities. Okay, lots of different things to do. Don't be fooled by this one. This one's easier than you might think. It's a 0 with a multiplicity of 2. Okay, what makes that 0 is 0. Then we've got this one has a 0 of 4 with a multiplicity of 2. And there's a 0 of 5 with a multiplicity of 1. Again, it's just the exponent, whatever the exponent is. And then this one, a lot of people have a hard time with this one because it's going to end up being a fraction. Remember how that works. You're looking for what makes 2x plus 3 equal 0. So algebraically, 2x equals negative 3, divide by 2, x equals negative 3 over 2. That's the 0. Or since we're probably better with decimals, that's negative 1.5. Let's call that negative 1.5 with a multiplicity of 1. 1. I want to write a 1. There we go. Okay. So we've got negative 1.5 is right there. And we've got a positive 5, the black one. And 4 is the blue one. And 0 is the red one. So we've got those 4 different zeros, but we've got varying multiplicities. We can look at the end behavior because of the exponents. You have to kind of visualize what would happen if I multiplied all this out. Well, notice we've got an x squared, and this one right here would be squared. This is just to the first, and this one's just to the first. So it's a matter of how many x's there are, or how many exponents on the x's there are. If you total that up, that's x to the 6th. The first term is x to the 6th, and that tells me that's a positive and an even, so I know the end behavior is up and up. So without Desmos, I know that. The end behavior is up and up. So that means we're going to have up over here and up over here. But we want to know what happens, you know, a little bit more specifically, okay? So the first 0 we would come to is the green one, and that has a multiplicity of 1. So I know that's just going to go straight through like a line. That's linear. And then the red one has a multiplicity of 2. So I know that's going to act like a parabola, and it's going to bounce like that. The next one is the blue one, and that has a multiplicity of 2. So you can see what happens. It's going to have to dip down and come back up, and it's going to act like a parabola again at that point. And then the black one is 5 with a multiplicity of 1. That's just going to be a straight line. So it's going to have to come up here just like that. All right. So, you know, what you could do if you didn't have Desmos, you'd have to like make an XY table. And of course, we could make an XY table and plug in numbers like -1 or +1 or +2. You can plug in anything you want and figure out where the graph goes. I think it's going to be a lot easier for us to just do Desmos, though. Scale goes from -4 to 7. We don't necessarily have to do this. I think it's going to make it easier on us, though. And -400 to +400. Just makes it look a lot more like what we would see. Okay, we are looking for just any interesting points. We've already got the zeros, but we might want any kind of maximum or minimum points right there. So as I trace this from the end, it goes down straight through here, down to about negative 150. Whoa. Let's try that again. About to, what is it? Negative 1 comma negative 153. So about right there. And negative 2, negative 340 or so. Sorry, positive 2, negative 340. It's about right there somewhere. Okay, and 4.7, negative 40. Yeah, it's going to be about right there. So we can kind of see what's happening. It comes down, straight through, bounce, multiplicity of 2. There's a dip, multiplicity of 2, and another dip. There we go. It's a pretty good looking graph right there. We're looking for zeros, we're looking for multiplicities, we're looking for any kind of point of interest, like a minimum or a maximum point or anything like that. Number 9, use technology to help sketch. Well, we're just going straight to Desmos on this. So just type it in. Okay. Looks weird because of the scale. So let's just, I tell you what, you can just hit the home button and it'll go back to a 10 by 10. And that's pretty close. You want to pay attention to different points of interest. Well, it crosses at these two. There's a dip right there. Okay. It's hard because they're all kind of overlapping. Let me zoom in. Negative 1.94 and 0 right there. Negative 1.3 and negative 3.8. I don't know, there-ish. Negative 0.301, 0.4 comma 1.3, and 1. Okay, that's probably good enough. Let's stop right there. I think you've seen enough. Okay.